Are you kidding? Good afternoon, everyone. Thank you for coming back. We were all worried that once we let the audience out at 4 o'clock, they wouldn't come back, so thank you for being here. I am in a very privileged position to do what I do. I watch science happen, and then I write stories about it for radio or television or print. But I feel like a surfer on the cutting edge of our knowledge as we penetrate our ignorance and we emerge into enlightenment. That's what I do for a living. I watch science happen. And in watching science happen, and this is also a significant year for me, 2013 is my 40th year of doing that. Can you believe it? Wow. Anyway. But it's taught me a couple of things, that science makes you see the world in a way that goes beyond your intuition and beyond your five senses. It's a pair of glasses that you put on, and as soon as you look around, everything is different. And it has shown us that the way we actually see the world is wrong. And it's through science that we're starting to get it right. And that is why I would like you to ponder the question, what if everything we know is wrong? And the reason I'm asking that is because throughout almost all of our history here on this planet, we have been wrong in how we've seen it. So our lineage as Homo sapiens goes back, the whole lineage of upright humans goes back about 6 million years. And back then, somebody, and we don't know who, had an idea to change our locomotion. We changed from being knuckle-walking quadrupeds to upright walking bipeds. And when we did this, by the way, I don't think that was somebody's idea. That's not how evolution happens. It was an evolution of our pelvic joints that allowed our legs to point straight down instead of being permanently bent. But this revolution enabled us to look up. Our head is now a meter or so above the ground. Our eyes are pointing forward, not down. And our hands are free so that we can carry things as we walk. And we did walk. We walked out of Africa. It took a long time. It took thousands of generations. It actually took millions of years to do that. And as we did, we built tools with our opposable thumbs, and we emerged out of Africa into Europe and Asia, and we spread ourselves around the world. What a remarkable journey. But during this whole time, as we explored our planet, the way we saw it was actually incorrect. Because if you think about the way you see the world right now, you just go outside and look around, it looks pretty solid. Doesn't move, just sits there. You walk in any direction, doesn't matter which way you go, if you walk long enough, you will come to an ocean. So we live on an island. The sky looks like this big blue dome over our head. Actually, it's two colors. Half of it's blue, half of it's black, and it rotates around. And the sun is stuck to the blue side, and the moon and the stars are stuck to the black side. That's what it looks like. And it's no wonder why the ancient Hindu model of the earth was that. This is how you see the world to your five senses. Of course, the Hindu asked, what's the world standing on? What's holding it up? So why not put it on the world's biggest animals? So the elephants are standing on the back of a giant sea turtle that is swimming in that endless sea that surrounds us. That's not too bad. That's how you see it with your five senses. And when those elephants get uncomfortable, I guess that's an earthquake. How far we have come. How far we have come. It took so much science, it took so much engineering, so much technology, so much philosophy to go from this to the fact that we live on a ball. We live on a ball. It doesn't look like a ball. But there are as many stars under your feet right now as there are over your head. And not only that, it moves. It moves. There was a fellow named Galileo who got into a lot of trouble for saying that. But it moves. Do you know that since this time yesterday, you've been all the way around the world? You have. The world took you with it. And you're moving pretty fast. Victoria, which is right here, Victoria is moving right now around the center of the Earth at about the speed of a jet airliner. So if the world was to suddenly stop turning right now, all of you would launch out of your seats and hit me at 800 kilometers an hour. It would not be a good day for any of us. And then we're whipping around the sun, we're going around the Milky Way galaxy, the galaxy is part of an expanding universe. Wow, that's astounding. It's astounding that we know this, that we figured that out. And the pinnacle of this, of seeing ourselves in its true light, came in 1968 with this historic photograph taken from the moon. And just take a second to look at this, because there we all are. All of us, all of humanity, all of our history, everything that's ever happened here, all of our 6 million years on this planet, it's there. You also notice how flat the moon looks. Get close to a ball, it looks flat. But there we all are. Hold up your thumb. If the Earth disappears behind your thumb, you're at the right scale for this picture. From only the moon, which isn't that far away, you can hide the Earth behind your thumb. It's small, but it's alive. And so, have we figured it all out? Oh, and the last picture that was taken by a human being, by the way, was this one on Apollo 17, the very last mission to the moon. On their way back, they got a full Earth, they took this shot, and look what's in the middle of the picture. Africa, where we first stood up, where we first started making tools. By the way, only 24 human beings have seen the entire Earth in one shot. You cannot see this today. Our great Canadian astronaut, Chris Hadfield, and all those who've been up in the International Space Station, they're only 400 kilometers up. That's like here to Kelowna. And from the space station, you cannot see the entire Earth. On this scale, the space station's about... Okay, that's what you see. You can see the curve, but that's about it. You gotta really get away from it before you can see the whole thing. We can't do that today. So only 24 astronauts who went to the moon are the only humans to see this. So this picture was the last time that the Earth was photographed using an actual camera in a person's hand. The same hand that got free 6 million years ago. So, have we figured it all out? Does that mean that everything we know now is right? Not quite. It turns out we once thought we had it all figured out, and it's very dangerous to do that, to say, oh yeah, I got it all figured out. Here's a picture from the Hubble Space Telescope, and this is a very deep, deep space picture. So every dot in that picture is a galaxy, not a star. So that means that every smudge there has about 100 billion stars in it, if not more. But you'll also notice towards the left side of the picture that there's a circular distortion. It looks like somebody's holding a lens up in this picture. And actually, there is a lens there. It's called gravitational lensing, and this is where gravity bends light. Einstein predicted that, and he's since been proven right. But in order to get gravity, you have to have an object. You need a planet or a star or even just a cloud of gas. You need something to make that gravity. Gravity just doesn't happen by itself. The problem is, there's nothing that we can see there that's making the gravity that's distorting that light. There's something there, but we can't see it. It's called dark. It's matter, and it's called dark matter. When scientists don't know what something is, they say dark. That's scientific speak for, I don't know. So it turns out that dark matter actually comprises about a quarter of the universe. 25% of the universe is made of dark matter. Not only that, those galaxies are being pushed apart by the expansion of the universe. Now, we know the universe expands, we've known that for a while, but only within the last decade or so, we've discovered that not only is it expanding, it's speeding up. There's something pushing it outwards even faster, going against gravity, and we don't see it, so they call it dark energy. Dark matter, dark energy. These two things are out there in the blackness. We don't see them. And you know something? They make up more than 95% of the universe. More than 95% of the universe is made up of stuff that we haven't got a clue what it is. Which is why the people at the Large Hadron Collider got so excited about finding the Higgs boson. Because it could introduce a whole new level of physics that'll look at that stuff. And we're trying here in Canada as well to try to find dark matter and figure out dark energy. So we're still in the dark about how we see the universe. When you look up on a dark night, you say, oh, look at all the stars. That's not all that's there. The blackness actually contains more than what you see in light. So we are still more ignorant than we are knowledgeable. Our cutting edge still has a long way to go. So here we are on our planet. We've become a super species. And we know that ever since the 1800s, when we started burning fossil fuels, that the planet is warming up. We are the first species to actually change the chemistry of the atmosphere. And that's a scary thought. So we know that it's going up. There's no debate about that in the scientific community. The so-called debate is among industry people and politicians, but it's not among the scientists. So what are we going to do about this? What are we going to do about this fact that we are now changing the planet itself? As we look at ourselves, we now show up from space. You can see humanity from space. This was a project called the Black Marble that was done by satellite, but when Chris Hadfield was up on the International Space Station, when he was looking down, they had quite a remarkable view. Now, this is a very sped-up animation, or sped-up movie of what they were seeing. And just look at how much of the planet we have covered. The white flicks, by the way, are lightning, but all the orange ones are us. So we're just down there. Our fires are now visible from space. Our fires are so bright. We're just down here burning up. We're burning everything up. It's amazing what we're doing. And you know, in nature, the things that burn the brightest are the shortest lived. The things that burn the brightest are the shortest lived. And here we are burning really, really brightly. Can we keep doing this? Can we keep doing this? What is our future as we look ahead, as we emerge into that darkness? Well, I have a plan. I have a plan. Let's have a party. I want to have a party, but I would like to hold off on this party for just a little while. I would like to hold off on our party until we have doubled our time on this planet. So we've been here already for 6 million years. How about if we have another party in 6 million years from now? Can we have a party in the year 6,000,2013? Right. Could we do that? Can we reach it? Can our species make it for another 6 million years? Will we look the same? Will we have evolved into something else? I don't know. Will we still be on this planet? Will we even be in this dimension? I don't know. But could we make it? And if we want to make it, we have to start planning for this party right now. And there are a few things that we can do right now to plan for this 6 million year old party. One, let's stop giving our garbage to the future. Let's stop giving the future our plastic, our nuclear waste, our toxic chemicals that we're putting into the soil and the water. Let's stop giving them our carbon dioxide, our heat. Let's just stop that right now, okay? Just cut it off, okay? Let's stop giving them our garbage. Second, let's ask ourselves a question. And the question is this: can we keep doing this? And this can be anything that we do today. Anything in your life from the time you get up in the morning till the time you go to bed. Can we keep doing this for 6 million years? Can we continue to burn up and eat up everything on the planet? Can we continue to cut down forests faster than they're growing back? Can we continue to force species to go extinct at a rate that hasn't been seen since the dinosaurs disappeared? Can our numbers, our own numbers, exceed 20 billion or more? Can we do that? And if the answer is no to those questions, then we have to think of alternatives. But we can do that because we are smart. We're really smart, and we're good at making tools. So, for example, energy. Do we have 6 million years worth of fossil energy on the planet? No. Okay, what's going to last for 6 million years? Well, there's 6 million years worth of sunlight. That's going to be around 6 million years from now, a lot longer than that. And in fact, there is more energy falling out of the sky every year from the sun than all of our fossil fuel reserves. We're just not very good at catching it. Yeah, we have solar panels and solar farms, but they're not very good. Let's get better at that. Let's just get better at capturing the energy that's around that we don't dig out of the ground. We can do that. Maybe it's in the form of a big satellite in space where you can put it up where the sun shines 24/7, gather it up there, beam it to the ground on a microwave. Do you know that one of those satellites, and by the way, this has been already engineered and thought about, one of those satellites could power all of Victoria, Vancouver, and Seattle. One satellite could do that. But we're not doing it. We're too busy getting giddy over the fact that we can make a lot of short-term money burning stuff that we dig out of the ground. So this is just technology, it's knowledge. In terms of our own numbers, that's a little more difficult because that's not just a scientific issue, that's a political issue and a social issue. But we could start with that by perhaps giving women equal rights around the world. That might help. So there are a lot of things that we can do. But along the way, as we come up to answers to these questions, we have to keep the big picture. We have to keep that 6 million years in mind. We have to keep the single planet idea in mind. If we don't, if all we think about is ourselves, if all we think about is the economy, if all we think about is our own country, our own family, we are narrow-minded, and in fact, we're as narrow-minded as we were when we were just looking around on the ground. We've got to be open-minded, which means keeping science alive, having a scientifically literate society. We don't have to become scientists, but know science and know that what we don't know exceeds what we do know so that we can make intelligent, wise decisions. We can do this, and we need to do this because this is it. This is it, okay? This is it. There are probably lots of other nice planets out there that we're going to find, but they're going to be really far away and out of reach. We can't even go to the moon, for God's sake. This is it. So let's deal with this one first before we start thinking we can go running off somewhere else. We can do that, but we still have a long way to go. You know, we can't even predict the weather beyond a week. We don't know when the next hurricane or typhoon or cyclone is going to hit. We don't know when the next volcano or earthquake is going to happen. We still have a lot to learn. But we're smart. I believe we can do it. See you in 6 million years. Thank you very much.